just see the whole.
Be careful, or make your fall. Oh, okay.
If you think about it, this is similar to the concept of limits that we learn in school, right? So, what is the limit actually? Actually, the limit is the value of the function that approach when the input x gets closer and closer to a certain point, even if the function doesn't actually reach the value. This is for the notation. There are also many kinds of limits. So, how do we find the limit value? The first is substitution method. The substitution method is the most basic way to find the limit value. This method involves directly substituting the value into the function f(x). Then, there is the factoring method. If the substitution method produces an indeterminate value, such as, then the function must be factored first, then it can be substituted. And the third is the method of multiplying by the conjugate. If the substitution method results in an irrational limit value, then the function is multiplied by its conjugate root, and then substitution can be applied. And finally, there is L'Hopital rule. If the substitution method produces an indeterminate value, so we can use L'Hopital rule. But we have to check whether the function produces indeterminate form. If not, then we use L'Hopital, then it could be wrong.
Polynomial limit. What are the polynomial limits? A polynomial limit is a limit involving a polynomial function, something like f(x) equals to 2x cubed minus 5x plus 7. And the good news, they're usually the easiest limits to solve. Why? Because polynomial limits are the nicest one, friendly, no drama. Why? Because polynomials are continuous like this, smooth like a freshly paved highway. They have no jumps, no holes, and no hidden bricks. And because they're continuous, to find a polynomial limit, you usually just plug in the number directly. For the simple example, we have lim x approaches to 3x squared minus 5x plus 4. And since polynomials are smooth and continuous, we can simply substitute x equals to 2. And we have, we have 3 times 2 squared minus 5 times 2 plus 4 and equals to 12 minus 10 plus 4 equals to 2. And the final answer to the limit is 2. Yeah! Guys, sometimes direct substitution gives you 0 divided by 0, which means we need algebra first. And for the example, we have lim x approaches to x squared minus 4 divided by x minus 2. And if we substitution x equals to 2 in the limit, we have 2 squared minus 4 divided by 2 minus 2. And we know 2 squared equals to 4 and 4 minus 4 equals to 0. And 2 minus 2 equals to 0. And the final answer we have 0 divided by 0. Okay. And because if we substituting x equals to 2, we have 0 divided by 0, so we can search the factor of the x squared minus 4 in the limit. And we know the factor from x squared minus 4 equals to x minus 2 times x plus 2. Okay, and if we use in the limit, we have lim x approaches 2, x minus 2 times x plus 2 divided by x minus 2. Okay, and next we cancel out the x minus 2 like this. And we have lim x approaches to x plus 2. Okay, and if we substitution x equals to 2 in the function in the limit, we have x plus 2 equals to 2 plus 2 equals to 4. And we have the final answer.
Right hand limit and left hand limit. What is right hand limit? Right hand limit when x approaches a from the right hand side. If x approaches the value L, it can be said that x is greater than a. The symbol like this. Limit fx when x approaches a from the right hand side equals L. And what is left hand limit? Left hand limit when x approaches a from the left hand side. If x approaches the value L, it can be said that a is greater than x. The symbol like this. The existence of a function's limit is determined if the value of L from the right hand limit and left hand limit is the same. For the example, like this. Continue of a function. What is the continue of a function? A function fx is continuous at the point x equals a if it satisfies the following three conditions. When fa is defined, limit fx when x approaches a exists, and limit fx when x approaches a equals fa. This means the function's value at that point equals the limit value as x approaches that point. For the example like this. This is limit fx when x approaches 1 from the right hand side equals with limit fx when x approaches 1 from the left hand side. Now I will explain about infinite limit. Infinite limit and infinite limit occur when the value of a function increases without limit or decreases without limit. As x approaches a certain value or goes to infinity. And the symbol limit fx when x approaches a equals delta, or limit fx when x approaches a equals minus delta. This means the function's value does not have a specific limit, but increases or decreases without limit. Objectives of infinite limit: determining the behavior of a function around a certain point, determining vertical asymptote, describing functions with infinite value. You can see this theorem. Now I will explain about the infinite at limit. The limit at infinity is the value that the function fx attains as x approaches infinity or negative infinity. The symbol like this. As x gets larger, the value of the function gets closer to 0. Objective of limit at infinity: understand the direction of a function's graph as x grows without bound, and 2. To determine a function horizontal asymptotes,
to understand the maximum or minimum limit of a function at the end of its domain.